So for this unit, in Unit 2, we're going to be moving into the pieces of language, starting with phonetics. So we'll be doing an intro of what phonetics is and starting to look at some of those pieces. And in the next several lectures, we'll dive deeper into other pieces of what makes phonetics what it is. So when we think about what phonetics is and what it entails, we're referring to the scientific study of speech sounds. So there's lots of different areas of inquiry that might be interested in sound more generally. So physicists are interested in sound, musicians might be interested in sound. This is more specific and a scientific study specifically of speech sounds. So the different kinds of sounds that we use in human speech. And this is broken into three branches or fields of study that are all related to each other, but cover sort of different aspects of it. So we have the acoustic branch, the auditory branch, and the articulatory branch. And it's that third one, the articulatory branch, that we'll be focusing on in this class and that we'll be spending these lectures on. This unit will be focusing on that, and we'll refer to these articulatory aspects throughout the semester. I'll briefly introduce those other two, and then we'll start diving into articulatory phonetics. So acoustic phonetics, is the first one that we'll talk about, and this is concerned with the physics of sound. So this is the sound form itself. So what is the actual physical sound wave, the actual production that is coming out of our mouths when we're making these sounds? And what this branch is concerned with is looking for the timing. So how long does it take to produce a sound? What are the different patterns we see when sounds interact? What kind of tones are there in the sounds? What kind of stress is happening? And when we look at this in acoustic form, it's usually done in a computer program that ends up creating an image kind of like what you see on your screen. So the top part, the waveforms, show you how much energy there is. The bottom part, the spectrogram, shows sort of where that energy is. So the lower areas are lower frequency, the higher areas are higher frequency, and there's more energy in the darker spots. So when you look at this, you can see what kind of sound is actually being produced. So this is a word from Zulu, and this is the word imiti. So let me play this for you, and then we can talk a little bit about it.
Imiti.
So you can see at the bottom the different segments, imiti. And as you're comparing that to what you see above, you may notice that the darker areas in the spectrogram are where the vowels are, where there's more energy coming out for those vowel production, and there's different shapes to it based on which sound is being produced. And if you study acoustic phonetics and you're used to looking at these, you'd probably be able to look at this without the sounds listed below and understand what is happening and which sounds are being produced. The next one, auditory phonetics, is concerned with the perception of sound. So this is interested in the things that we hear, the influence of adjacent speech sounds. So what happens when we have a sound that has different sounds next to it on either side, as well as things like external stimuli. So what happens when there's background sound? What happens if you see something that contradicts the kinds of things that you're hearing? And this is something that is important because when we speak quickly, sounds aren't always taking place in the same part of our mouths, but we're still perceiving them as the exact same sound. We tend to group sounds together to represent a sound in a language. And so this is tested with what's known as a categorical perception test, where you can place slightly different waves of sound, slightly different frequencies, and sort of see where a listener is going to hear one sound and where it sort of switches and they'll hear a different sound, because we tend to categorize sounds as a sort of bubble, a sort of group of wavelengths and group of frequencies that all sound the same to us, even though they're slightly different. And so you can play slightly different computerized sounds that move from one sound to another and sort of have the speaker determine where they hear one versus where the other one starts to be heard instead. And this is going to change from language to language. So in English, we may start hearing P sounds until we start hearing a T, and most speakers of English will switch it around the same point. But in a different language, the switch point might be slightly different. They might hear a different sound switch at a different point. The part that we're going to focus on in this class, though, is articulatory phonetics, and this is concerned with the production of sound. So how are we actually making the sounds? How are our mouths moving? How are we able to produce particular sounds? And this is going to be what we focus on in this class. So even though we're just focusing on this branch, all of these are interrelated, and if you study phonetics, you're going to rely on all three of these different aspects to get a full picture of how sounds are working in languages of the world. But what we're going to focus on and what we're going to see in these next several lectures involves taking a little bit of an anatomy lesson where we're going to look at the different aspects of our speaking tract to understand what kind of changes and configurations are necessary. It takes very specific anatomical changes and configurations to make the sounds of human language. And this is one of the reasons that human language is so complex compared to animal communication systems. We have the ability to move things very minutely within our mouths, within our oral tract, in order to make different sounds that we recognize as distinct sounds that we can put together in unique ways. And this is something that animal communication systems typically don't offer. And when we're looking at these different anatomical regions, there's three main regions or subsystems that are responsible for our speech articulation. And we'll focus on the first two in this lecture, and then we'll spend the next couple lectures on that third one, which is going to be the most crucial for understanding the sound productions. So the first one, the subglottal region, is our lungs and our trachea or windpipe. The second, our larynx, which is where our vocal folds are, or you may hear vocal cords. And then the third one, the supraglottal, or the vocal tract, includes our oral cavity, our nasal cavity, and our upper throat, anything that's above our larynx. And we can look at our little drawing of a linguist here, and you can see where these are taking place. So the lungs and the trachea in the lower portion is our subglottal system. The larynx itself is going to be its own kind of subsection. And then everything above the larynx would be the vocal tract, the stuff that we'll focus on in the next few lectures after this. So if we start with the subglottal system, our lungs and our trachea, this is going to be useful for us in a lot of very crucial ways. So as you can imagine, our lungs are very important for being able to speak because our lungs are providing airflow. And this is something that we need in order to speak, especially with all of the sounds that we have in English. But in addition to that airflow, we also need our trachea or our windpipe. We can use our lungs for airflow and do things like breathe, and we're not necessarily making noise while we're doing that. So it's going to take some other aspects to get speech sounds out. And the trachea or windpipe helps us funnel the airflow through our larynx, through our oral cavity in order to make sounds. And this is something that's very important because it helps us push that air through it faster and allows us to make the kinds of sounds that we need to make. And in English, which are the sounds that we'll focus on in these lectures and in this class, these are the sounds you'll need to be familiar with, you'll need to understand. We have two sounds that are made entirely in this subglottal system. So our first one, our H sound, our H sound, is one of them that is made entirely in our subglottal system. It's just sort of forcing that air through without really doing much else within our vocal tract, and it gives us that H sound.
Aha.
And then we have another one known as a glottal stop. And this is where the glottis just closes to restrict airflow and then opens up to allow the airflow. So it's sort of like an absence of sound. So if you hear that little pause, that pause is the glottal stop. And we don't really think of this as a sound in English all the time, but most speakers use this sometimes. So things like uh-oh, that little pause between and o, or in Hawaii, or in many dialects of English, we use this in other areas with things like mitten or kitten, where instead of making a T sound, we're actually making that glottal stop. So instead of saying mitten, we're saying mitten. And you're just closing the glottis for a second and then releasing it. And that's taking the place of what might be a T in some other dialects. Is also very important, and this is where one of the three descriptions that we use for consonant sounds in languages of the world comes from. So our larynx plays a very vital role in speech production because it contains our vocal folds that vibrate during voiced sounds. So this is important because they're not always vibrating for every sound we're making, and this creates what we refer to in linguistics as voicing. So if we vibrate our vocal folds, we have a voiced sound. If we're not vibrating them, we would have a voiceless or an unvoiced sound. And we can try this out together. We can do a little experiment. And in this experiment, you can hold your hand up to your throat, and you can do this along with me as I'm explaining. If you hold your hand up to your throat and make an S sound, S, S, you shouldn't feel anything vibrating against your fingers. But if you put your hand up and make a Z sound, Z, Z, you should feel a vibration happening. And so that difference in vibration is whether or not your vocal folds are vibrating. And the only difference between an S and a Z sound is whether or not we're vibrating our vocal folds. You may have noticed your mouth didn't move at all when you were making those two different sounds. They're made exactly the same way in our mouth. The only difference is that voicing distinction. And it looks a little like this in your throat. So if you have an S sound, it would look like the one on the left, where your vocal folds are relaxed and they're open and they're not really moving. They're allowing the air to flow through unobstructed. But with a Z sound, you can see that they tighten, they close together, and they're going to vibrate against each other as the air is moving through. And that creates that voicing sound that you hear with voiced sounds. And it looks a little something like this. I'll just...
Whenever you're ready. Pitch. Middle pitch, very soft.
Play a few seconds of this, but this is a video recording of someone using their vocal folds. The next area are larynx produced just based on where the energy is for each of those sounds. So you can see in that example that when they're making those different vowel sounds, you can see the vocal folds moving together, vibrating against each other. They're actually moving much faster than you're seeing because the video camera is only able to capture so many frames per second, and our vocal folds are often moving much faster than that. So it doesn't always show quite as fast as they're actually moving. But that gives you an idea of the importance of our vocal folds in that voicing distinction. And then finally, what we'll focus on in the next couple lectures is the vocal tract. So this is everything above our larynx, our supralaryngeal or supraglottal area. You'll typically only hear me refer to it as a vocal tract. It's much easier to say and remember. And this contains most of the structures that we manipulate in speech. So even though our lungs play a vital role, even though our larynx plays a role in voicing, which is one of the 3 major descriptions we use for consonants, the vocal tract is going to be responsible for those other areas of change. So the parts of the vocal tract that we're using to make a sound are going to be responsible for the place of articulation, what we'll focus on in the next lecture, of a particular sound. And you'll see as we look at this last little graph before this lecture is over that there's a lot of different terms. There's a lot of places within the vocal tract. We have our lips, our teeth, we have the hard palate, the velum, the uvula, the tongue. These are all different aspects. So the next few lectures will have a lot of terms, a lot of terminology to think about, a lot of different places to remember. And we'll have time to practice, we'll have time to talk about that, and we'll go through them one by one and look at examples of each of them as we're diving into what these different pieces entail and how we use them to create speech sounds. As always, if you have questions, you can shoot me an email. I encourage you to schedule some office hours using the office hours link there, or please bring questions into our synchronous Zoom classes. You can type them in the chat at the beginning, or you can ask them during our Q&A period as well.